we're talking the matrix from chapter 11.4.
These are examples of two matrices that you could see. The red one is a basic 2x2 matrix. The green one, however, is a 2x3 matrix. And the way you distinguish between or define the matrices is the number of rows, which in this case is 2, by the number in each column, which is 3.
Adding matrices is simple. Simply add numbers as you normally would with the corresponding number and the added matrix.
So in the example above, take the 2, add it to the negative 11, and that gives you the negative 9 that you see in your answer. For the next term, add 5 plus 4, and that gives you 9, as you see. Add 4 to 8, and that gives you 12. And then add 9 to negative 5, and that gives you 4. And then you leave your answer in this notation. We just discussed the addition of two matrices, and the same goes for subtraction. However, we can also multiply a matrix by any given number. Matrix A is a simple 2x3 matrix. However, we can multiply it by k, which can be any number. Let's make k equal to 2. So we're multiplying each term in the matrix by 2. So multiply negative 2 by 2, and that gives you negative 4. 4 by 2, that gives you 8, and so on. And that will give you the answer here.
So how do we deal with this kind of equation in blue? So let's just follow our rules of multiplying matrices, and we'll have a 3 out in front of our A matrix. And a 2 out in front of our B matrix. Then we'll keep going, multiplying the correct numbers. And from here, it's just keep on following our rules of subtraction. Simple as that.
So now we'll go into the multiplication of matrices.
The important thing to remember is that there can only be certain kinds of matrices that can be multiplied together.
Take the following matrices, for example. The one on the left is a 2x2 matrix, and the one on the right is a 1x3 matrix. In order to be able to multiply the matrices, this number must be the same as this number. Now, if this was the example, and the second matrix was 2x3, these numbers would match, and therefore you could multiply the two. And if that's the case, the resulting matrix, after multiplying, will be a 2 by 3. Alright, so first let's check to make sure we can actually multiply these two matrices. This matrix is a 2 by 3 matrix, and this is a 3 by 2 matrix. Since these numbers are the same, we can multiply the matrix, and it will result in a 2 by 2 matrix because these two numbers are both 2. So you take the 2 in the first matrix and multiply it by the 1 in the second matrix. Take the 1 in the first matrix and multiply it by the 2 in the second matrix. And take the 3 and multiply it by the 3. And so that will give you 2 plus 2 plus 9, which is equal to 13. Now, if you're setting up the answer in a 2 by 2 matrix, as we already decided, the 13 will go in the top left. So now you take the first row in the first matrix and multiply it by the second column of the second matrix. So you take 2 times 0 and add it to 1 times 1 and add that to 3 times 2. And that will equal 7, so you put the 7 in the top right corner of our 2 by 2 matrix. And now you do the same with the bottom row of our first matrix. So you take 1, multiply it by 1, you take negative 1, multiply it by 2, and then you take 0 and multiply it by 3. And with that, you get 1 plus negative 2 plus 0, and which will give you negative 1. You put the negative 1 in the bottom left corner of our 2 by 2 matrix. And now finally, we'll take the bottom row of our first matrix and multiply it by the second column of our second matrix. So you multiply 1 by 0, that gives you 0. And then you multiply negative 1 by 1, that gives you negative 1. And then you multiply 0 by 2, that gives you 0. And your answer, which is negative 1, will fit in the last spot of our answer, which is the bottom right part of our matrix. So now let's attempt to do a word problem using matrix multiplication. Our goal will be to find the final grades for Thompson, Max, and Kathy in the Intro to Pre-Calculus math class. In the Intro to Pre-Calculus class, the quiz grade is worth 40% of your grade. The test grade is worth 45% of your total grade, and the homework grade is worth 15% of their total grade. Now we have to go about arranging this in a vertical matrix. Go about putting the numbers in the matrix like you would a normal percentage and put it as a decimal. So that's 0.4 for the quiz grade, 0.45 for the test grade, and 0.15 for the homework grade. Thompson gets an 81 quiz grade for the year, an 87 test grade, and a 90 homework grade. I got a 72 quiz grade, 75 test grade, and 95 homework grade. Kathy got a 55 quiz grade, 70 test grade, and a 61 homework grade. Now we set those grades up to a horizontal 3x3 matrix, and we multiply just like we would on the other matrices. So we multiply it out and find that Thompson's final grade in the class was 85.05. We perform the same operation with my grade. Add up 32.4 to 30 plus 14.25, and we get 76.65 for my grade. And when we multiply out Kathy's grade and add it up, we find that she got a 61.9 in the class.
The matrix method can also be used to solve a system of equations using your calculator. First thing you want to do is go to second matrix, so it'll open the matrix menu, and then go over to edit. From edit, you select the matrix that you would like to edit, and seen in the picture, you can adjust the dimensions of the matrix. Looking at the system we have right here, we directly place the constants attached to each variable into our matrix on our calculators. So this first row here on our matrix correlates with this side of the expression or equation. This is the same for the next rows in the matrix. The first matrix we set up does not take into account the answers to each expression. The next step is to create a separate matrix that will take these numbers and place them in their own matrix. To solve, again click second matrix and select the matrix, the larger one, the 3x3, in this example, the 3x3 matrix that has the constants of each variable plugged in. Once our first matrix is selected, we click inverse of x to find the inverse and then multiply it by the second matrix we set up, the 3x1. Once you have the equation set up, as indicated in this picture, enter the problem and it gives you the values for your variables, leaving you with a simple way to solve a system of equations. Yeah.